Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. And today we're going to look at concrete and in particular geopolymers. I'm Ian Riley, CEO of WCA and your host on the Clinker Factor. The cement industry has been working on decarbonisation for many years, and we've been using the three traditional levers, but we've only recently started to pay more attention to some of the other technologies that can help. And we like to think that concrete is an indispensable material and one that we need for urbanization. And generally, we also think that means that cement is too. But once in a while, it probably pays us to ask if the two are necessarily connected. So we held a forum, WCA held a member forum about geopolymers in July. And today I'm talking to Liz Gilligan, who is the founder and CEO of Material Evolution, who are not only using geopolymers, but also combining that with machine learning. So Liz, welcome. And perhaps we can start by asking you to introduce yourself briefly and how you came to be involved in concrete.
No, thanks, Ian. So my name's Liz. My background is I have my PhD in sustainable cements. Before that, I was working at Foster & Partners. So I helped design the concrete used on different kind of buildings, different kind of campuses, and was really obsessed with how we make cement, why we're making it this way. Then went on to do my PhD in it, realized I didn't know anything about cement, which was a fun experience. So during that, was really obsessed with how we reduce emissions, why we're making things a certain way, the value chain involved in cement manufacturing. So I convinced my parents that we would convert our garage into a lab. We bought our first machine off eBay, and that's where we developed our first product, was in my parents' garage. It's not quite the Silicon Valley story you would hope for. It's not as sunny in Devon as it is in San Francisco.
But sunnier in Devon than it is in Teesside.
Definitely, at least 10 degrees warmer. So I was kind of obsessed with how we make things, how we scale things, and how kind of that personal responsibility of how we reduce emissions. I think climate change is the biggest kind of crisis of our time. It felt wrong of me to sit in academia and watch that going on and write nice papers about it. So I decided that me and the co-founders would start a company and try and change the cement industry a little bit.
Great. I mean, I think that's the attitude that we need if we're going to make a difference in terms of climate change. But can I just ask you something about your background there? Because the cement industry has been trying to get architects, specifiers, developers interested in different cements and different concretes and working together on climate change for many years. And generally speaking, the architects in particular tend to regard, cement as being a rather small part of the overall problems. When they think about green buildings, if you look at LEED standards and BREEAM standards, then it's not it's not a particularly important part of the standard, but it was something that you picked out. What was it that made you feel that this was a key to addressing climate change?
I think it's just the big emissions numbers, and the amount of use globally. So it's not kind of a niche problem, it's a niche, like it needs huge solutions, it needs huge overhaul. So for me, it was this obsession that we use it, we take it for granted, it's this material we just use, but none of us really understand why and how we can make it better. And I think probably a lot of the barriers I found was the understanding piece. Cement and concrete are quite complex. The chemistry of them is complex. How we design them is complex. So it's understanding and creating a universal language for that I found really interesting, was that how do you make it so that you can still create the things you want to and build the same ways we always have, but actually we don't have to have those emissions pieces. So like all good nerds, I decided that we'd go into cement chemistry and see how we could tweak that.
Okay. So tell us a little about what Material Evolution is doing.
So Material Evolution is using an alkaline fusion process to create cements from waste. We're using machine learning algorithms to allow us to keep consistency and speed up the development time for new materials. We are waste agnostic, so we believe that it's not going to be one material that saves the world. We actually think it's going to be a multi-stage approach to decarbonisation.
When you say material agnostic, I believe you're looking at some old slags, is that right? And then you have other things in mind?
Yes, so interested in the UK and the metal and mining kind of slags. Mm-hmm. Also interested in different slags that are coming out, natural pozzolans, new industrial byproducts, old industrial byproducts, hazardous waste, bio waste. For us, materials and how you use them don't have to be defined by what they are, but what are their characteristics? How can you manipulate those? How can we change crystalline structures to amorphous structures? And how can we do that without heat?
I think the doing it without heat is very important, because one of the things that allows you to do is to look at more local solutions. Generally speaking, if you have a process that requires heat, it tends to be larger scale, it requires different permitting and so forth. Mm-hmm. And if you can avoid that, then local solutions are definitely interesting. But maybe we get to circularity a little bit later in our discussion. So tell us where you're starting, and what are the materials you're looking at, and what's different in the way you're approaching this from a traditional slag cement or a traditional geopolymer.
Yeah, so where we're starting is with kind of steel byproducts. We know that the industry knows them, so we think there's a big trust piece. We understand that we're pretty much asking people to discard what we've been developing for the last 100 years and try something new. So we think there's a big educational piece in that. So looking at steel slags, looking at how we reduce them, scale them, what does that look like? And looking at kind of starting in the precast industry. We are working with a ready mix supplier as well. So we are looking at both of those marketplaces. Obviously, they're completely different beasts to tackle. How two things that are made of the same material can have such different properties is always amazing. But starting with precast, block paving, kind of looking at that low risk, but still uses cement. So how do we reduce that piece? And then also looking at that ready mix piece of how do we start to prove out ready mix? How do we start to understand that as a concept? How do we start to develop the admixtures that go with that?
If we compare what you're doing with traditional geopolymers, sodium hydroxide geopolymers, is it the same concept, or is it something different that you're trying to do?
Yeah, so we think that we're different in the fact that our activation process is using this alkaline fusion process. So we can use a lot less activators. We are surface changing materials. So we are creating a amorphous phase on the surface of material that is unreactive. We are kind of forcing phase changes through mechanical activation, sonic microwave activation. So we're looking at how you change a material through its manufacturing process, which allows us to use these unreactive slags or lagoon ashes in different ways.
Okay, so it's really looking at materials that traditionally have not been used in concretes, whether through geopolymer or just a traditional SCM. Is that right?
Yes, so we're looking at kind of the alternatives, what people don't really use, and how you can scale them. I'm really kind of focused on creating these reactive phases in these materials. So right. We focus on kind of these high alkaline environments to force these phase changes so that you create a sticky cement substance afterwards.
Yes, I think that's a very important issue, because one of the things, of course, is that the blast furnace slag is pretty well used and is in relatively short supply. So if you have a product that is using GGBS, then, although that specific concrete may have low CO2 footprint, arguably you're not really helping the overall picture, because somebody would have used it anyway. So the fact that you're using new materials that people are not currently using, I think, is very important in terms of being able to say that it's an impact on the overall climate change picture. I was just going to ask you if that was part of the concept of in choosing the materials. I mean, I guess there are economic advantages as well of choosing materials that are not currently used.
Yeah, so I think the great thing about GGBS is it fits into the standards, and I think there's a huge standards play, right? Because it's a conservative industry, let's be honest. Everyone knows GGBS. So these new materials we're actually bringing in combination with GGBS at the moment. So we're combining them. So it's not a complete shock to people. They have something that they know in there, and we dilute that down. But I think that the reason GGBS and fly ashes and things like that are so used and these newer materials aren't is because of standards. I think there's a big standard play on how can you use these materials? Why are we so prescriptive on materials and not on mechanical testing? Why haven't we developed it so that we do all the testing? Because I believe that the testing is really important. As a good scientist, I think we should test it as much as we possibly can. But I believe that materials and kind of these standards need to change to be more flexible, to be more understanding about, I suppose, the next revelation or revolution in cements in concrete technologies.
Yeah, so at the moment, are standards constraint in terms of what you're able to offer, or are you able to pick segments of the markets where they're not having much of an impact?
Yeah, so I think it's really customer dependent. Some customers don't mind if we don't fit into standards, which I think is a really big change from where kind of we've ever been before. And I think that there are obviously industries that are much more conservative, and so they should be. If you're building a foundation out of it, we want to make sure that really is going to last. So we are being really targeted to where we fit in the industry, how we're kind of building out that momentum. And for us, it's really choosing the right key customers. So we want people who get it, who want that longevity, who understand our vision for how we think the cement industry could look. And I think that's where we're really focusing, is those key customers who can help with that growth plan.
So I think you already have some customers that you're working with.
Mm-hmm.
What's the scale of your business at the moment, and what are your plans over the next year or two in terms of scaling that up?
Yeah, so there was currently 18 of us on the team, many scientists. We're very science heavy. For us, obviously we developed this new process, but we want to kind of really keep pushing how we develop and scale materials. We're looking to have our first pilot facility, which will produce 30,000 tons up and running next year. And then we're looking to scale up from there to produce a bigger factory that will produce the products at different scales. For us, we see this as kind of a show and tell for the industry. So can we produce these at scale? Let's show people we can produce them at scale. Okay, let's show them we can produce it at a bigger actual, because 30,000 tons is nice, but it's boutique, right? It's a boutique scale of cement. Like, how do you produce it at the big scales? Because it's nice, but it's not really the same. So how do we produce this at scale to prove to the industry that this is a scalable technology, that this can solve an issue? And I think that's kind of what we're really going after. We spent a lot of time with our customers on factory floors. We understand that you need sign off from the operatives to the CEO of that company. So we think we're different from others, where we spend a lot of time with customers. We spend a lot of time asking why, how, why wouldn't this work? And I think that's what we're looking to kind of scale. We think that there has to be, for these new technologies, a customer service element, an education element. We don't think you can just throw them at people and expect them to get it. So we're spending that time. And I think for us, we want to look at how we can feed into that picture of reducing the emissions. We'd like to get to a gigaton of carbon removal by 2030. So how can we do that part? Is that licensing? Is that partnering with people? How do we scale and use the industry's existing infrastructure to build that out? And what does that look like? Are the questions we ask ourselves internally.
So, given the scale of your ambition, so I mean, a gigaton of carbon, is this a cumulative target or a per year target?
It's cumulative at the moment. Until I'd love for it to be per year. I do think that there is a stage after 2030 where it could be per year. And I think it's, how do we work with the existing network? How do we work with the experts who make this product on a global scale?
So in any event, even if it's cumulative, it's still hundreds of millions of tons of material per year. Yeah.
Mm-hmm.
What's your sort of vision for how to get to that sort of scale? And does the machine learning component of what you're doing play a big role?
Yeah, so the machine learning, I think, allows for others to do it. So for us, we want to look at a licensing model eventually. So the machine learning part becomes part of that, so that you get consistent products every time over materials that aren't consistent, so that you can be sure that your cement is going to be the same every time. And I think understanding that and bringing that into the manufacturing process, so that we're manufacturing in the most lean and smart ways possible, is really key. We're looking at kind of raising funds. So we're doing our Series A at the moment to look at the scaling piece. For us, we really understand the relationship-driven nature of the industry. So how do we build out relationships? How do we partner with the right people for scaling? And how do we really understand that industry problem better than anyone else? So that as a young startup, we're nimble. We can move really quick. We are agile. We're used to fires. So how do we create that in our products, create that at scaling, kind of different possibilities?
Okay. So I think another aspect of what you're doing is looking at material circularity. I worked in China for many years, and I remember meeting with NDRC, the National Planning Authority, if you like, at least 10 years ago. And they were very keen for the cement industry to play a role in using slags that were currently unused. So I think what you're doing is very much what they were hoping the cement industry would play a role in. And how are you thinking about material circularity, and to what extent do you think we'll move towards more locally based solutions over time?
Yeah, so I think that material circularity is kind of the way forward. We have so many resources available to us. Why aren't we using them? They are the urban mines of the future. How do we really address them? How do we get them at scale? Where do we source them? How do we understand and map them? Because I think the biggest confusion that we've always found as a company is that there's no real maps for them or understanding where any of it is. And it only becomes a problem when you want to build on that land, or when you've got no more space, or when you've had a contamination into the water table or something else. Like they're seen as kind of issues and problems, but how do they become resources? How do they become revenue streams? So for us, we're really trying to map and understand that, because I think that the amount of kind of resources we have in the UK, we have 190 million tons of historical steel slag. We could use that. Why aren't we using that? So for us, how do you map them? How do you then look at mining them? And how do you keep consistency over those materials? Are some of the key problems that our machine learning algorithms help us with, our different kind of analytical techniques help us with. So for us, it's how do you scale them? Because they're huge resources, but they also come with huge liabilities for the companies that currently kind of look after them. I think there's a big piece on circularity, on kind of how do you do that at a global scale, and then how do you become local? So I think that's another way that we're looking at using these algorithms is, can you understand what's available locally? And can you decentralize cement production? Do we not have to have mega factories anymore? Can we have them more locally? Can we have them in smaller locations? Can they move from resource to resource? And how does that work? I mean, we don't have all the answers right now. These are things that we're playing with. Maybe it doesn't work, but is there a way that this could work? Is there smaller kind of units if they're lower capex? Is there a way that you don't have to build mega factories, that if the capex is 5% of a normal cement plant, can you put them in smaller locations? Can you scale them in different ways? And can you really kind of question how cement is produced and distributed?
Yeah, I think that's a very insightful perspective. If you think about circularity from the standpoint of either a municipality or a developer, these days you have an area that you're redeveloping, then the pressure is very much to start by saying, okay, well, are the buildings I can reuse in this area? Okay, if I can't reuse the buildings, can I use the building elements? And if I can't reuse the building elements, can I reuse the materials? So the starting point is not a blank sheet of paper. The starting point is essentially what you already have there. And different projects in different areas are not necessarily served by mass production of standard products. So I think the concept that you have there is very much fitting with the pressures on the developers and on the project owners to find local solutions. So what have you found in terms of the attitude of existing players? You mentioned you've been working with concrete producers. What about other people in the supply chain? Have you talked to developers? And I'm sure you must have talked to architects, given your background.
Yeah, so we've been talking to the architects. The architects are very excited about it. For us, the biggest constraint is the manufacturing supply at the moment. So that's where these kind of factories will really help with the supply. I think that the last 2 years, the industry has changed, I think, in how it talks about these materials, how it talks about sustainability. I think it's really growing up in its kind of the language it uses to talk about sustainability, its goals. And I think it's great that most companies now have a sustainability roadmap. Like, that's great. 5 years ago, if you had one of those, you were a hippy dippy company, right? Who were maybe doing something. So I think to have that huge kind of step change in how sustainability is seen within kind of corporates, I think the attitude has been very much a bit skeptical when we talk about alkaline fusion sometimes. We're asking for a big leap, but I think what's been proven is when they get it in their hands. For us, we're always like, yeah, that's great, but how about you touch it? How about we deliver you some? Like, we can talk the technicalities all day, but until it's on site in the operative's hands, I don't think it really sells anything. So that's what we spent a lot of time doing, is kind of understanding what the pain points are. I think a lot of concrete producers want to be able to kind of reduce their emissions, sell to their customers, because they're getting pushback from their own kind of clientele, is that they want emissions. Emissions are the top of kind of people's minds. And I think there's kind of almost like a disconnect at the moment between the concrete producers, the architects, and the cement producers. I think there needs to be a more succinct story told and more developments across those, which I know is very hard because I think they all speak slightly different languages. So getting that connect across those disciplines is really hard. So creating something that goes across all of them. What we do in the company is we probably send a different person to each of those and then bring that story together. But I think it's a kind of a big opportunity for the concrete and cement industry is creating those narratives and those dialogues across, because I think we're all learning, right? We're all learning how we reduce emissions. We're all learning how we do that at an industrial scale. And I think if you can have really strong dialogues across that value chain, it will speed up the implementation of new technologies and carbon reduction.
Many of our listeners work for the cement industry in different countries around the world. Do you have a message that you would like to give to the cement industry?
It's a good question. I guess I think that there should be more open dialogue. I think there should be more transparency. I think that cement is the villain. Cement is a great product. It does amazing things. How do we make it more kind of reduced? How do we use it in the right ways? Where do we use it the best? How can we work across different standards? And how do we start that dialogue so that we kind of are all upskilling at the same time? How do we all understand that language? Because I think it's a global problem, right? This isn't, oh, this one company's not doing it right. It's a global problem. And I think the only way it will be better is with more transparency and better collaboration.
Yes, well, thank you very much. I wish you all the best with your business. I think it's very much pointing in the right direction and is an inspiration for others who are trying to innovate in the cement and concrete area. So thank you for speaking to me today, Liz.
Thank you so much, Ian.